Good morning. This is an extra session for lateral and student on UNIX operating system course, right? So we are going through the chapter number 1 and chapter number 2. See, chapter number 1 and 2, these are meant for, I will be covering that, remaining will be covered by Rangana. So we are going through what is an operating system, okay, what is the architecture of that, what are the services provided by that, all these aspects that we are going through, right? Please look into these two chapters I'll be covering, and there are set of programming exercise given in syllabus at the end, which I shared in the our Google class. Okay, I will make you to go through all these things. Okay, this is essentially you need to cover, right? From examination point of view also, and also from learning point of view, right? And all videos of old regular class, whatever we have covered, they are made available. Please go through that quickly, right? So let me quickly take you what is that we have done. Okay, summary. When I was talking about operating system introduction, I told operating system is a software which will act like a resource manager, right? When I talk about the resource manager, right, what are the resources? You have a process, you have memory, you have devices and all, right? So when you look at the process, right, uh, what all services it provides. It allows you to create a process. It allows you to delete the process, right? You can suspend, you can resume, right? I mean, all these things happens, right? And there will be synchronization, right? Communication among the process, right? And a kind of a deadlock between the process. A deadlock in the sense the two processes cannot proceed, okay, because they are holding something and waiting for something. These aspects you will study in the next semester operating system course. Probably we will be continuing that, right? No, but when you, and also we said that one process is nothing but the programming execution, right? So when when you run a program, okay, we call it as a process, right? So now let's look into the other slide where, okay, we talk about the, when you run the program, the running program will take a different state and all. Please look into that, the process state. And when you run the program, that is called a process. Process is a unique ID. Like your university seat number USN, process is a unique ID, and based on that ID, the entire management activity takes place. Are you clear about that? Praveen Dhoni is acting like a CR of lateral entry group. Praveen, are you in? Okay, that's good. Right. Please remember, all of you, every day 8 o'clock. Right? Yes. Now look at this. So when you run the program, right, it is brought from the hard disk into the memory. It is a new. That's what we say, the new process. Right? So when it is admitted, okay, there are many new processes. When it is admitted, okay, into the queue. In cinema theater, you find the queue, different queue and all. So we call it a queue. It is ready, right, ready to run. But process is not, processor is not allotted for this, right? When a process is allotted, okay, let me use a marker for this. That will be better. Right. Okay, now look at that. It is a new, when it's getting brought from the hard disk to this, and it is being admitted, okay, here and waiting in a queue. It is in a ready state, right? Then one of the process which is ready to run is allotted a CPU, and it starts executing. That it moves into the running state. And when a program is running, don't think that it's only your program that is running, right? So there are several programs running as a part of a multi-programming environment to enhance the throughput of the CPU. Okay. So what happens when you are running? Probably you may wait. You may wait and get into waiting state because you wanted to do input-output operations, or you are waiting for somebody to give an input from the keyboard. You are waiting. Okay, without that input, you cannot proceed. So when you are in the waiting, the CPU doesn't sit with you, doesn't run your program only, right? It may switch. We call it the context switch, right? So during that time, what happens is, I'll use another color, right? See here, look into that. See what happens when you are waiting here, your program. So what it does, it picks another program and start executing that. It may happen that that program may complete its task during the block time and exit, and it may get terminated. Right? Then one more program it picks and start running, and it may happen that that is also waiting for some of the input, and it gets into waiting. Right? Waiting state, you have a queues here. Even in ready, you have a queue here. I can you all admitted it, there will be queue here. Queue. Right? Then see, look at that, your earlier first program which was waiting, it has completed its IO operation and again comes and sits okay here. Right? I'll change the color now of the pen. Right? Please wait for that. Right? Now what happens is the one which was okay admitted into the ready queue, from waiting state to the ready, it picks that one and start running that one. So what happens is, right, it will allocate some block of time, say 500 milliseconds for okay process 1. Right? If it completes within that, it's all right. If it doesn't complete, it will put into the waiting. Right? Then it will pick the another process P2. Right? Then it will pick another process P3 after the block period okay is over. Right? Then assume that there are only 3 processes. When it complete all the 3 processes part execution, what happens is again it will pick P1. Again it will pick a P1 and it will continue that one from wherever the point it has stopped. Are you getting this? Are you clear about that? How okay, in a round robin fashion it continues. Maybe it may be round robin, right? When it picks okay the ready program, the program which is ready or the process which is ready from this state, it picks which one it will pick. Which one it will pick? It depends. As simple as first come first serve could be. I'll call it the first come first serve. It could be. 1 minute, people are waiting here. Right. Or it could be 1 minute. I'll use a pen. Right. It could be okay. High priority based. Every job or every program may be assigned a priority. Right. You paid more money, so you're given a high priority, fast tag. Right. Or it could be round robin fashion. Round robin, right? What it does, it takes a P1, P2, P3. Then again it comes P1, P2, P3. Then again it comes P1, P2, P3. Then again P1, P2, P3. During that, okay, if you complete, it will terminate your program and sends it out. Okay, a new program will be entered, but all will go in a round robin fashion. Right? This is an important thing. All of you have to go through this. Are you clear about this? Praveen, I'm asking all
Yes, sir.
aspirant student. And
Yes, sir.
Rashmi and Manoj can add their voice also as an expert. Alright, other student, regular student, if they are joined, if they have got any doubt, they can unmute directly and ask me a question. Are you clear about this?
Yes, sir. Yes, sir.
Okay, right? Lateral entry student, please remember, Dhoni, you are the class representative, right? If anything they wanted an extra class, I can communicate to all people, right? And I shared the list and their mobile number. You communicate with each other, right? And if at all you wanted, you can ask any teacher to have an extra class in the evening also, in the night also, right?
Okay, sir.
Without any hesitation for any
Okay,
course,
sir.
right? But my regular class will be there as per timetable, and extra class I'm taking morning 8 to 9 all days, right? If
Okay, sir.
any change is there, I'll tell, don't give that slot to anybody because I have to take some programming exercise also, right? Dhoni, is it all right?
Okay, sir. Okay, sir.
Right, that's good. Right, now let's get into, I told you, once a process when a program enters, right, it is called a process. Okay, it starts executing. A program, okay, in a running state, we call it a process. And every process has an ID. Right? Let's look into the first program, Himarashmi, whatever that we have done. okay, process ID, right? So I will be writing a program showing to you, right, the how to know the process ID of the program that is running, right? Lateral entry student, please look into a program which is running. It wanted to know its ID. Who am I? That is the first exercise we'll be doing it, right, today, and again tomorrow we'll continue. Tomorrow 8 o'clock, right? We will have 1 minute. What has happened? Power is on, but 1 minute. Battery is running low. Why it is? Just a minute. Yeah. Right. Okay. Shall we get into the program now? Hello?
Yes, sir. Yes, sir.
Okay. Now, okay, let's look into the program. Simple program, right? See how do we do it, right? And all of you see that whatever that we do, everything is available, okay, in the learning material section of the Google Class. You can get into, and whatever the class coverage we are doing, okay, there you have got the videos. You can view more, get into the first class, right, and see all the things, right? All the things you can see it there. Now, see here the program, first program, to display the process ID, again, parent process ID, right? Program to display the process ID. See here, this is a PDF, right? Is this visible to you? Is this visible to you? Dhoni, is it visible to you?
Yes, sir.
Right. Now look into this. What is that we are doing? Include stdio.h header file for all IO operation. Then you have a main function and you have got the parameters. They are called, okay, command line arguments. We will see that later, very quickly tomorrow. Then I'll be declaring one variable called PID. It's my variable. Is of type integer. To begin with that, I use integer. Later we do correction. Himarashni, Manoj, look into that. We do, okay, declare this and we do correction. Then there is system call called get PID. There is system call called get PID, right? When I call that one, it will give the process ID, get process ID, that's called get PID. It will give the PID of the program, this program itself. Then you are displaying that and you are returning 0, right? Is it clear? Simple.
Yes, sir.
Right. Now let's run this program and see. Okay, this is the UNIX environment. Okay, I'm showing to you, and everyone need to install the UNIX. Here is the program. Right. Include stdio.h, types.h. Now all these things we will see it later. Right. Then I have a PID. Right. Then get PID is a system call. Then what I'm doing is I'm displaying the value returned by that system call get PID, right? So I will run this and see that one. Okay, sample input, I have given a comment at the end of the program. You develop a practice of doing this. Right? When I run this program, I'll get something. This process ID is unique when a program is running. Right? Next time when this program you run, the operating system allocates a new ID. It is not a permanent. It is a permanent as long as the program is running. Are you clear about this? Hello.
Yes, sir.
Right. Now let's look into that. Okay. I've given a different number here. My program ID, this one is 34 process ID. See here. CC, right? The name of the program I given 34 process process ID dot C. This is how you compile. Do you agree? Do you agree?
Yes, sir.
Right. So you compiled it. Then you are running /a dot out. I hope that you all people have done C programming under UNIX environment. Am I right?
Yes, sir.
In your diploma, okay, yes. Okay, so you know how to run the program in UNIX environment, all of you?
Yes, sir.
Oh, that's great, right? Now question is that one dot forward slash. What is the meaning of that? Right? What's the meaning of that? Right? So you work out. Right? Now look at that. When I run this, right, process ID is 3001. Now again I'll run it. Process ID is 3002. The different ID. Whatever free IDs are available, it allocates that. Are you clear about this? Hello? Are you clear? Praveen Dhoni.
Yes, sir. Yes, sir.
Right. When Praveen Dhoni says yes, all lateral entry students, it means yes. Otherwise, you can unmute and talk to me without any hesitation. Right. So this is the program that's available to you in the learning material section. Please go through that. Program to display process ID. Now I'll continue with that. To display process ID and parent process ID. Every process has a parent. There is something like a parent and child relationship. Are you getting it? So now let's look into that process ID, right, of parent and child. See here. Same program you are extending. Okay, I'll be declaring two variables. One is PPID, parent process ID. Other one is process ID. Right? So process ID is get PID and parent process ID is get PPID. Right? So when I run my program has a parent. My parent is again their parent. That is the hierarchy you find in a UNIX operating system. And for everyone, there is something like a godfather, right? And we call as a unique process. When you boot a system, right? Okay, there is a unique process that runs, which will initialize and bring all the process which are running, right? And so your program finally. Got it? Right? So let's see that one, who is the parent ID for me and who is that, okay, for this particular program, right? So let me get into the Unix environment live and show you that. I'll minimize this, right, get into my folder. Right. Now that was 34th program, right? Probably 35th process ID. Process ID. Okay. Let's see that one, 35th, what it is. Yeah. Okay, this is different. Yeah. Now what is that we do here? Look at that. There is a one more small change, right? So when I'm displaying the process ID, so what I'll do is I will put this particular program in the infinite loop, right? In the infinite loop, I'll put it. Are you getting this? Right? And I'll run this program in the background. So how to run the program in the background? Okay, when I run this one, a.out, put an ampersand in front of that. It runs in the background. I will make it to run infinitely and run in the background. Then what I do is process ID, okay, displays that. Then I use a ps-e command, which will list all the process running in the system. So I can see here 2807, where it is 2807, right? 2807 is a.out. It shows that this process is running, right? You please refer the video and do it, right? Yes. Shall we run this program and see? Shall we run this program and
Yes,
see?
sir. Yes, sir.
Right. Some of you can take a screenshot also. Otherwise, it will be there in the video. That video will be made available today evening. Right. Now let's look at that 34 process, the 35 process ID I'll run. It will run in infinite loop. It will run in the background, and then I will execute ps command and see. Right. See here. I'll clear the screen. Clear. Right. CC. Right. 35. The program name I given is like this. Process ID dot c. A.out is now ready, right? What I do is I'll run A.out in the background so that foreground I can continue doing it, right? So A dot out ampersand, it runs in the background. It doesn't terminate because I put a while loop. Look into that. It is in the infinite loop. Now process ID is 3078, right? Now my command is available. Now program is running in the backdrop. But in the foreground, I can do any other work. So I want to list all the process running in the system, PS minus E. Right? Now 3028, I will look into that. There are many process running here. Okay, where is that 3028? Okay, look at that. 3028 is my okay program. A dot out. Do you agree? Yes.
Yes, sir.
Right. Even I executed a command PS, even that will also receive the process ID. Look at that. PS command. Do you agree? Dhoni?
Yes, sir. Yes, sir.
Yes, that's good. Right? That's good. But 3028 is running. Okay. Now I want to okay terminate that. How to do that? Kill okay 3028. Right? So now that 3028 is no longer available. Again, I will do PS minus E. Let's check that one whether 3028 is there or not. 3028 is not there at all. Okay, is that clear?
Yes, sir.
Right? Kill is a command. Kill is a command not to kill the program. Kill is a command that is used to send a signal to the process asking the process you terminate. Do not go by the name of the command kill. Kill is to kill the process. No, kill is to send a signal to the process to terminate it. From placement perspective, we are talking. Placement perspective, this course is a very important thing. In a recent one of the interview, right, people asked one, can you name, right, few Unix command? 20 Unix command you list it. Himarashmi and Manoj, I shared with you, no, when that interview was over in a regular class.
Yes, sir.
Right.
Yes, sir.
Name 20 Unix commands and tell how they work. Over. Right? As a finishing, as a last question in the technical interview. Right? And you should know that. Are you clear about this?
Yes, sir.
Okay, that's good. Right? So this is the Dhoni, this is the way that we'll be completing the syllabus quickly. Is it okay? For details, you can
Yes, sir.
refer the video and get into. Okay?
Yes. Okay, sir.
Oh, that's great. Right. Now let's look into another program. 36. Parent and child process. Right. Look at this. Right. In the PID, process ID is this, get PID, parent process ID is this. Right. When you run the program, it says that one process ID is this, parent ID is this. But who is my parent? I want to know. Who is my parent? Right. Let me run this. CC, right, 36, process ID dot C. Hey, what is this? What is the name of the program? Can anybody help me?
Here you have wrote PROC sir.
Ah, PROCESS. Okay, right. Okay, CC, right, 36. Help me. PROCESS ID dot C. Right, I'll run this. Data dot. Look at that. Okay, I get this. Right? I get this because it's the infinite loop. Right? 30. And I'll run it once again. Control C is to terminate. Right? So it says that when 30580 is my ID, this program, my parent is 2664. But who is 2664? Right? Again check PS minus E. 2664. Are there any 2664? Yeah. 2664. What is that? Bash. Right? So this is called shell. Right? The every terminal has its own shell. This is a command interpreter. Whatever the command you type it from the terminal, it takes that one and pass it to the operating system and gives a response back to you. Command line interpreter. Command line interpreter. Are you clear about this? We will see about the shell related things maybe in the unit number 4. Raghunath will deal with that because first unit and second unit I'll be dealing and remaining unit will be dealt by Raghunath. It's common to all. Very clear?
Yes, sir.
Right. Please look into that one. You'll be trying all these things today. For any details, Manoj, okay, you send your name, email ID, mobile number, all boys will talk to them, right? For the help. And quickly, on day-to-day basis, you have to complete this, right? Now, the another thing which I would like to take to you is, right, I want to create my own process. How do I do? When you run a program, your okay shell, right, your operating system create that as a process and runs it. But I want to create my own process, right? So we are doing it by okay what is called as a fork and v fork, and we call it as a child process. A parent can create a child, and there is a relationship between the parent and child, okay, and that is what you will see, right, in this okay program to show the fork system call here, right? So here is a program which will help you how to create your own process, right? See here, is this visible? Is this visible?
Yes, sir. Visible, sir.
Right.
Yes, sir.
Yeah, line number 1 to 13, whatever you see, this is the program. It is called parent program, right? There is a system called fork. When you run this fork, it creates a child. And what happens is, whatever the code that follows after the child, sorry, after the fork, that is shared by, sorry, okay, that will be executed by both parent and child. Code from the immediate line will be executed by both parent and child. Please remember, child get a copy of the right parent, right? Child get a copy of the parent. Are you getting it?
Yes, sir.
Right. So this is the first program that we'll see about how to create a child process. And look at that. Child also will say that I am executing the okay, I'm executed by both parent and child. The two message you will get it. This is a line that is being shared by both parent and child. So parent executes once, child also executes once. Is that clear?
Yes, sir.
Yes. So we will run this and see. Fork, where exactly is a fork? Yeah. Okay, 37 fork.c. We'll see that whether this is what I have to show. No, this is, yeah. But this is a little okay, bigger one, right? Let me check if there any other program. No. Mm, No. So I will take I'll take this fork. Okay, please look into that. You can take a screenshot in between also. See here, include stdio.h and standard library.h. Whenever library is required, appropriate library you will be including that. Which library is required, all that things you have to search. Now what happens is, say int PID, right? I declare a PID, right? Now, right, you can call outside, but what I'm doing is I'm calling that in the if statement itself. If PID equal to fork, when you create a child classes, it will return a value, and it will return a value less than 0 if there is an error in creating the child process. Are you getting it? So if it is successful, then the line next to the fork will start executing immediately. Right? What is that? This will be executed by both parent and child. But I wanted to see that child will then do its work, parent will do its work. How do I ensure? Right? Now look at that. The PID value thus is 0 in case of the child process, right? In case of the parent process, it is the PID of the child process. Now, whether child runs first or the parent runs first, you don't have a control. Operating system will schedule that. So what I'm doing, if by mistake a parent is running first, what I do is I'll make it to sleep. Sleep is another system call. Earlier we are seeing fork system call, sleep system call, command kill we are seeing it. Like this, I'm forcing it to sleep for 2 seconds. Is it second or not? How to check it? Refer the manual. Right? How to refer the manual? Right? At the command prompt, write man SLWP, the system call or command, whatever you want to check. It will give a manual here. But it is getting terminated in next 5 minutes. I'll close. Okay, when it closes automatically, all right. Okay, tomorrow again we'll meet. But now I'll continue. It will give a manual here. You can check it. Right? Now, right, child says that when I am a child, my ID, parent ID, my ID is this, and parent says that I am so and so, my ID, my parent ID is so and so. Let's look into that 36th program. CC 36, right? Not 36, 37 for dot C. 37 for dot C, right? Executed. Now see dot / a dot out. Child is running now first, then parent runs because in parent I made it to sleep. So child says that my ID is 3101. My parent is 3100. Right? But now look at the parent. Parent says that I am 3100. Now correlating with this, you understand that okay, there is a relationship between the child and parent. And parent says that my parent is 2664. Who is 2664? If you do it, PS minus E 2664. 2664. It is a bash, it is a shell. For every program, right, shell, right, is a parent process. Then for the bash 2664, somebody else will be the parent process. Right? So by this you have something called init. Somewhere you have an init process. Right? Init process. That's the initialization. It is a godfather for everyone. Here you can see. Right? So I wanted you people try all these things given in exercises here, right? and tomorrow we'll see EXECL. This we will see it and proceed. And from a theoretical aspect, we have seen the state diagram of a process, right? Then I told you context switching, right? When CPU is being allocated, the existing one, right, is removed, and a new one is being brought. And the policy being used for scheduling purposes, first come first serve, or round robin, or priority based, something like that, right? And all these have their own queues, right? Something like a queue, and they come and sit here, in a ready queue, whatever that is there, picked and given a CPU. If it is waiting, it gets into appropriate queue, right? Again, it comes back here. Again, CPU allocated. When program terminates, it goes out of that. So at every state, you have a queue, and that queue maintains all the details. But what are the details, right? Process, details, we will see it in the next class, and a few programs. Is it okay, Dhoni? And all people?
Yes, sir. Yes, sir.
Lateral entry people, you might have got introduced to operating system also. Am I right? In your diploma.
Yes, sir.
Yeah. So you should quickly understand all these things and keep moving. Right? Refer the syllabus, their textbook is being given, refer it. So we'll quickly move to the program and focus on that. And question bank is there, start preparing the answer for the question bank. Right? So with this, we come to the end of today's session. Please wait. I will see alternate then. Right, as many as 23 students have participated, right? All lateral entry students have participated, right? Except one or two, right? So I'll end the meeting. Tomorrow, sharp 8 o'clock will be meeting. Is it all right? Dhoni, sharp.
Yes, sir.
15 minutes before the 8 o'clock, everyone should get into, my WebEx, this one. The moment I switch on, you'll be in and get into that, right?
Okay.
Bye.
Okay, sir.
Right? What about Himarashmi and Manoj? At what time we'll continue? Or today evening, shall we get into?
Sir, we also have regular class tomorrow at 8 o'clock.